So good morning, and thank you for joining this ROVE Tech Talk. My name is Mark Trojanowski, Principal Solutions Architect and Security Practice Lead at ROVE. This is our fourth installment, and today I'll be speaking about Cisco Umbrella. So I have a bridge to sell you, and again, that phrase is often used to indicate that a particular statement or claim can only be believed by someone who is very gullible. George C. Park, back in the early 1900s, was an American con man. He made his living conducting illegal sales of property he didn't own, often New York's public landmarks. Famous one is known as the Brooklyn Bridge. So again, he did this quite often, and unfortunately there were a lot of gullible buyers out there, or gullible individuals out there that thought this was true and believed them, bought it, and actually would go ahead, for instance, on the Brooklyn Bridge would actually have to be removed because they started setting up toll booths. So this started many, many years ago, and today it still happens to where we have gullible users. So one of those forms that are used today is phishing. It's a form of fraud in which the attacker tries to learn information such as login credentials or account information by masquerading as a reputable entity or person in email, IM, or other communication channels. So we've all gotten those emails. Some are done very well, some not so well, but quite often our users will try to click on that link or submit a request to try to get information, and quite honestly, it turns out to be a malware, then over to a ransomware. So how do we change that? What do we do with our users today? Our users are probably our biggest security risk, and I saw this meme the other day and thought it was appropriate to bring up during this discussion. Again, we have all these firewalls, encryption, antivirus software, etc., and yet we have a user that can defeat that quite easily. And again, I think that's very true in today's world. So what's changed? You know, in the past, everything was contained basically within your network perimeter. All of your critical infrastructure, whether it be your servers, applications, data, and people. Security used to be more about building a taller wall around your perimeter, checking off the boxes for whether it was your compliance and HR acceptable use policies, instead of defending the business against data breaches and advanced attacks. Most security products were built as a closed system that couldn't integrate together or share intelligence. So very closed off. So again, what has changed? There are more corporate-owned devices accessing the internet from other networks. Apps and infrastructure are moving to the cloud. So users no longer need to connect to the corporate network to get work done. They use cloud apps like Salesforce, Office 365, and many, many others. And they don't always turn on their VPN, which means they're more vulnerable and you lack any visibility and the ability to provide protection to these users. And now we have branch offices connecting directly to the internet. And it's very expensive to backhaul all the traffic to a corporate network, so more branch offices are moving towards that direct internet access. But while you're saving money by not backhauling the traffic, you're losing that security protection. So users and apps have adopted the cloud. In fact, 49% of the workforce is mobile today. And in a recent survey, 82% of those respondents admitted not to using a VPN at all, at any time. Cloud adoption and SaaS app usage is expected to increase as it's increased over the last 2 years. In the next 2 years, we can expect it to increase another 70%. And 70% of those enterprise branch offices report direct access or DIA. Why does this matter to us or to your customers? Because these changes create new security challenges that we didn't have in the past. First, traditional network and web security, while necessary on the corporate network, they're unable to protect roaming users and direct-to-internet traffic. And second, organizations have limited visibility and control for sensitive data and apps in the cloud. So security must evolve to address today's challenges and protect the modern enterprise. It has to protect users wherever they work. And like infrastructure, apps, and data, it has to shift to the cloud. It already has, but it's going to continue to shift in that direction. So how can we get there from here? And how do we provide that first line of defense? Well, one of the options that we have is Cisco Umbrella. Cisco Umbrella is Cisco's secure internet gateway. Cisco Umbrella provides first line of defense against threats on the internet wherever users go. So whether they're working at home, whether they're working at an airport, whether they're working in a hotel or a Starbucks, Umbrella provides that level of security support or protection. By analyzing and learning from internet activity patterns, Umbrella automatically uncovers attacker infrastructure, staged for current and or emerging threats, proactively blocks that malicious request before they reach a customer's network or endpoints. Because Umbrella is built into really the foundation of the internet and is delivered from the cloud, it provides complete visibility into internet activity across all locations and users. Plus, it is probably one of the simplest security products that I've seen to deploy and to manage. So let's take a quick look, and we'll start going through to where Umbrella might or fit within your environment. How do most users or customers protect their network today, or your endpoints? So think about where you enforce security today. You likely have a range of products deployed at your network or your corporate headquarters and branch offices, or on your roaming laptops or mobile devices that you provide to your users. What we hear from our customers is, despite the existing security products deployed, everything from firewalls to web proxies to email security to endpoint products, they're still dealing with too many malware infections and phishing attacks. There are many ways that malware can get in, which is why it's important to have multiple layers of security and hence having that first layer with Umbrella. So Umbrella with DNS. Umbrella can be really the first line of defense against threats by preventing devices from connecting to malicious or likely malicious sites in the first place, which significantly reduces the chance of malware getting to your network or really to your endpoints. Umbrella uses DNS as one of the main mechanisms to get traffic to the Umbrella Cloud platform. And then it uses it to enforce security as well. So DNS, as everybody knows, is the foundational component of how the internet works and is used by nearly, if not every, device within the network. There may be a few scenarios where it's not, but probably 99.9% of every device looks at DNS to be able to go on the internet. Way before a malware file is downloaded or before an IP connection over any port or any protocol is even established, there's a DNS request. So let's kind of go through some of the key features for Umbrella. So it's fast, reliable cloud infrastructure. So when customers connect to a cloud security platform, performance is still critical. We want security, but performance is still as critical and probably more important to your end users. To you, the security is important, but if the security or the performance is not there, your users will find another mechanism or means to be able to bypass security. So performance is critical. It cannot break or slow down internet connections. So the Open DNS network, now Umbrella, was established back in 2006. Since that time, they've had 100% uptime. They also have peering relationships with over 500 ISPs, which allow them to resolve requests far faster than any other recursive DNS. And in many instances, customers actually report that there's a boost in speed after they direct their network devices to use the DNS at Umbrella for their recursive lookups. It's an open platform, so leveraging bidirectional open APIs, customers can easily integrate Umbrella with their existing tools to automatically add to the platform or enhance other systems that they already have, extending the protection and enhancing the information that they're receiving. Predictive intelligence. So this intelligence enables the ability to uncover malicious domains, IPs, and URLs before even used in attacks. And again, as I mentioned earlier, and I'll probably mention it again, one of the easy deployments I've seen. There's no hardware to install or software to manually update, and customers can leverage their existing architecture to provision thousands of network devices and laptops. And then there's broad coverage of malicious destination and file. So now, not only does Umbrella have the power of identifying the malicious domains and IPs Umbrella had before, but also have coverage for malicious files that are attempted to be downloaded from risky domains, and this is through the power of AMP. So Umbrella provides visibility and protection for all of your internet traffic. Specifically, Umbrella provides visibility needed to protect internet access across all your office locations, all devices on your network, and lastly, but probably more importantly, our roaming laptops. Umbrella provides visibility into sanctioned and unsanctioned cloud services. So now you can uncover new services being used and actually see who's using them and identify the potential risk that you have before you. As attackers try to infiltrate networks with different tactics, Umbrella also provides coverage and visibility for all ports. So we're not just talking about DNS, we're talking about all IP ports. As the internet moves, again, continually moves towards HTTPS, more destinations will require SSL decryption to effectively see within that packet and block it. Umbrella provides visibility and protection for HTTPS destinations without, again, adding any latency. So as I mentioned, OpenDNS Umbrella is built into the foundation of the internet, provides enforcement without delay. Umbrella uses DNS to enforce security, but exactly how does it work? So we'll walk through kind of a scenario here. When Umbrella receives a DNS request, it first identifies which customer the request came from, and then obviously which policy to apply. Next, the Umbrella will determine if the request is 1, safe or whitelisted, 2, malicious or blacklisted, or 3, risky. So for safe request, we would route the connection as usual, no change. For malicious requests, we route the connection to a block page based on the policies that we already have defined within Umbrella or whatever's on that current whitelist or blacklist. And then for risky requests, we route the connection to Umbrella's cloud-based proxy for deeper inspection. And we'll talk about that a little bit more. So let's dive deeper to understand exactly what gets enforced inline and then what's analyzed offline. So at the DNS layer, we see both the domain request and the IP response. And at the IP layer, when the roaming client is installed, we can even see direct connections. So the combination of Umbrella statistical models and Talos plus partner feeds enforce approximately 7 million malicious domains and IPs and protocols. Plus, customers can build their own custom domain lists using the GUI or APIs. With all dispositions, the new telemetry continuously powers predictive updates. So in the case of a proxy disposition, we'll see the URL request and then file hash at the HTTPS layer. So let's kind of go for a few minutes and look more closely at the Umbrella proxy. So when I had mentioned risky domains, you maybe was wondering what I thought. So let's start there. So most phishing, malware, ransomware, and other threats are hosted at domains that exhibit malicious behavior and are blocked at the domain level accordingly, but some domains host both malicious and safe content, so that becomes, a little bit more of a risk. An example of that would be Reddit.com. So we need more info to actually determine if these are safe or malicious. And unlike traditional web proxies or gateways, they examine all internet requests, which adds latency and complexity. The proxy, the Umbrella proxy, only intercepts or inspects requests for risky domains. So once we have identified a risky domain, what do we inspect? So starting with the URL inspection, we use Cisco Talos Intelligence and Cisco Web Repudiation System, and along with other third-party feeds to determine if the URL is malicious. Customers can also create a list of custom URLs to be blocked based on their policies. So if the disposition is still unknown after the URL inspection and the web address is for a web-hosted file that matches one of the 150-plus file types, for example, PDF or JPEG, and many more, we look at the file reputation. We then use AV engines and Cisco Advanced Malware to block malicious files before they're actually downloaded. So really the idea is to prevent connections before and during the attack. So Umbrella not only protects against initial infection, Umbrella also prevents command and control callbacks, or also known as C2 callbacks. So even if devices become infected in other ways, Umbrella blocks the communication to the attacker's server. So stopping data exfiltration or the download of ransomware encryption keys, C2 callbacks are blocked using the same DNS enforcement process described a moment ago. And in the event that the malicious payload is designed to bypass DNS and use a direct-to-IP connection, Umbrella goes beyond DNS to provide malicious IP blocking and enforcement as well. So let's think about what happens when a machine is infected. Often malware use command and control callbacks to communicate with the attacker for additional instructions or to exfiltrate the data. In research done by Landcope, which is also part of Cisco, they found that 15% of C2 callbacks bypass web ports, the ports covered by traditional web security systems. So you most likely have a gap in coverage. You're only relying on your secure web gateway or perimeter security at that point. So additional research found that 91% of those C2 callbacks relied on DNS. So by using Umbrella, you have the ability to block vast majority or those vast majority of those C2 callbacks. So 15% of the C2 bypass web ports. Again, researchers analyzed millions of unique malware samples from small office lands for a period of over 2 years. They found that 15% of the command and control callbacks, which are commonly used to exfiltrate bypass web ports. So when Mandiant, for example, released their APT1 report, about half of the samples analyzed relies on non-web C2. Some of the most damaging botnet infrastructures responsible for ransomware and bank Trojans, Game Over, Zeus, Tinba, and a dozen others bypass port 80 and 443, so HTTP and HTTPS. 91% of the samples that relied on internet activity use DNS requests before a C2 callback. So the vast majority of what the next-gen firewall, proxy, sandbox, and other technologies can stop, Umbrella can block even earlier. Again, being that first line of defense. So let's kind of go through the anatomy of attack. So we have patient 0. Refers to the first machine infected with malicious code, but there's a common misconception that the attack lifecycle actually starts with patient 0. Once patient 0 is infected, the attacker does a targeted expansion to a similar segment, then a wide-scale expansion to all. Weeks later, traditional security vendors catch up, reverse engineering the code, and then finally creating a signature they push out to the customers in form of an update. But looking at the timeline in more detail, before an attack is launched, servers get spun up in the dark of the internet, the dark web. Domain registered, IPNs and ASNs allocated, and although threats continue to increase in sophistication, attackers often reuse really the same infrastructure in multiple attacks, leaving behind those cyber fingerprints. Umbrella uses data from their global network and their statistical models to uncover this information to stop attacks before patient 0 is even hit. So one of the key features of Umbrella is their view of the internet is like no other. The Umbrella global network includes 25 data centers around the world that resolve over 100 billion DNS requests from more than 85 million users across 160 countries every day. They peer with over 500 of the top ISPs, content delivery networks to exchange BGP routes, ensure routing requests are efficiently done and not adding any latency again over the regional DNS providers. So not only do they have a massive amount of data, but perhaps more importantly, a very diverse data set. It's not just from one geo or one protocol. So essentially there's 3 factors that make up Umbrella's threat intelligence. Data, security researchers, and statistical and machine learning models. So let's look at data. This includes Cisco's Talus feed of malicious domains and IPs, based on researchers' analysis of millions of malware samples and terabytes of data collected. As I mentioned, Umbrella resolves more than 100 billion daily DNS requests across its user base. Not only is this data massive, it's diverse. So it represents all markets, geos, and protocols. These two things alone give it an unprecedented view of the internet. The second key factor is that security researchers, they look at data and use advanced techniques like data mining and 3D visualization to identify patterns. And then lastly, the models I just mentioned, these models continuously run against all their data, all of Umbrella states to uncover malicious domains, IPs, URLs, again, before they even use an attack. So all the information is ingested in real time into what they refer to as a massive graph database. It then continuously runs statistical models, algorithms against it. More than a reputation score that looks at the past, both historical and live data is analyzed. So that's very key, not just historical, but live data, which gives Talos that kind of advantage over other competitors. These models statistically score the guilt of domains and IPs to determine if they're part of an attacker's infrastructure. So what I mean by guilt is there's guilt by inference, guilt by association, and patterns of guilt. And we're going to talk about a couple of those in the next couple of slides, examples of those. So domains guilt by inference. So when someone makes a DNS request, the co-occurrence rank model identifies whether domains are queried right before and after in a very short time frame. So identifying domains that have high co-occurrence scores can highlight a connection between domains regardless of what IP or network they're hosted on. So an example, if the two domains, c.com and d.com, are frequently visited right before or after the malicious domain x.com, this may mean that c.com and d.com are possibly malicious domains as well. They are domains guilty by inference. So co-occurrences allow customers to stay ahead of the attackers, proactively block those additional related sites or domains before the network is compromised. So the second one is patterns of guilt. So we mentioned that Cisco Umbrella resolves close to 80 billion DNS requests per day. So there's a spike rank that leverages that massive amount of DNS data, request volume, and detects domains that have spikes in their DNS request patterns using, again, a complicated sound wave graphing. This model recognizes when spikes in traffic to a domain match patterns seen with other attacks. So, for example, if the traffic to one domain matches the request pattern seen with an exploit kit, they'll block that domain before the full attack launches. And then we have predictive IP space monitoring, guilt by association. So predictive IP spacing monitoring takes suspicious domain from spike rank and observes its IP's open ports running services, OS versions, otherwise known as just the IP's fingerprint. That model then closely analyzes all of the IP hosted on the same server, identifying any other IPs that share that same malicious fingerprint. So for the IPs that share the same fingerprints, Umbrella will flag them with a high confidence as malicious. Then they'll quarantine or block those IPs and those malicious domains, even if the domains have not been yet created. This essentially provides predictive security and protect against emergent threats. So again, looking at real-time or predictive behaviors. So when we talk about efficacy, we talk about the depth and breadth of Umbrella of what data that they actually receive. So Umbrella discovers more than 3 million new domains daily. By analyzing all this traffic with statistical models, Umbrella identifies over 60,000 malicious destinations, domains, IPs, and URLs daily. So you not only need threat intelligence, but you also need the ability to act on this data. So being in the cloud, Umbrella has the horsepower to actively enforce more than 7 million malicious domains and IPs at the same time a DNS request can be processed. Appliances and hybrid cloud solutions can't come close to that scalability, which again makes this solution very unique. So we talk about, again, the ability to secure these locations or to secure these hosts or networks, but we also talk about the speed. So a little bit about the BGP peering. So at the exchange point, BGP route data with major ISPs and content delivery networks is exchanged. So there's over 500 established relationships with ISPs, as well as over 2,000 peering sessions. this is important because typically when you add more security, you also have to add more hardware to your network or more software to your endpoints and more gateways to your internet connection. This isn't the case with Umbrella. You already rely on a recursive DNS service to connect to the internet, and Umbrella simply builds in more reliable and faster alternative. So even when an authoritative name server goes down, which happened in a recent DDoS attack here, I think it was October 2016, Umbrella leveraged technology called SmartCache. SmartCache is a DNS record handling technology invented by OpenDNS that allows users of its service to access websites when they're inaccessible everywhere else on the internet. So just something very unique that you're able to still leverage and get work done within your environment without being, I guess, hindered by something like a DDoS attack here that happened recently. And then lastly, deployment. So again, Umbrella is one of the simplest solutions to deploy and manage. Because Umbrella is delivered from the cloud, there's no hardware, again, to install, software to manually update, and the browser-based interface provides quick setup, ongoing management, a very intuitive interface. And we won't get to the demo today, but this will be segment 2, where we'll do pretty much a demo for 30 minutes and go over the GUI itself and go through some of the capabilities and show the ease of use. Many of our customers deploy enterprise-wide in less than 30 minutes, and we've done this for quite a few customers, and they quite honestly come back and can't believe the ease of use and the ease of deployment. 2 ways to do it. You have your on-network coverage. You can protect all your devices on your network, even those you don't own, by just changing one setting in your network server or access point or router. Customers have several additional deployment options which provide more granularity for administration, specifically for policies and reporting. Customers can use lightweight DNS forwarder deployed as a virtual appliance, again, to embed the local IPs associated with the internet traffic so that administrators know which internal network made that internet request. And then for even more granularity at the user level, Umbrella can integrate with Active Directory. And then for your off-network coverage, if you currently are an AnyConnect user, you can use the built-in integration to enable roaming security. And then if not, Umbrella also offers a lightweight standalone client. So that concludes my session. Hopefully I gave you a little bit of information or details about the different components within Umbrella. As you can see, it's a very powerful tool. I think I covered maybe 25% of its total capabilities. I hope you're able to join me here in the next couple of weeks when we do an actual demo of the Cisco Umbrella GUI itself and go through some of the configurations and capabilities. Thank you.